All right, hello. We're going to talk today. The national standard is 5.NF.4.a. Okay, and the topic is multiplying fractions. Now, for some reason, when they teach this, it always seems to come on the heels of having learned adding and subtracting fractions. So I cannot stress this enough. You don't need to find a common denominator when you multiply fractions. Okay? So our sample problem is 1/3 times 1/2. And I'm going to model that over here. Okay? So please notice, if you look at it horizontally, 3 rows. So I am going to highlight 1/3 to represent that factor. Okay, I'm going to try to do it kind of quickly so it might not be perfect. Okay. All right. So if you see that, I've shaded in 1/3 to represent this factor. Okay. Now I'm going to highlight half of it. Okay, to represent this factor. Okay. I should probably be using green, so I might switch to see better. Actually, it looks pretty good. Okay. Now, what I need to draw your attention to is this section here where it's overlapped. Orange and yellow might not have been the best colors. Okay. But the half is this, this, and this. And the third is this and this. So this is 1/6 of the original. Okay, each one of these is 1/6. And this is what we're talking about. I'll put a little asterisk there. Why? Because that is our product. Because when you multiply a proper fraction times a proper fraction, you're not really multiplying. If you think of it in these terms, both of these values are less than 1. Right? Here's 1/2, there's 1, it's less, and there's 1/3. It's like you're taking 1/3 of a half. Okay? Now, so the answer is 1/6. And I want you to notice that 1/6 is less than both 1/3 and 1/2. Now, that's the conceptual piece, which is admittedly important. But in terms of actually multiplying a fraction times a fraction, you simply multiply your numerator times your numerator and your denominator times your denominator. You don't need to find a common denominator. That only applies to addition and subtraction. So in our example, 1 multiplied by 1 equals 1, and 3 times 2 is 6. So this is how, and over here this is more of the why. The concept, if you will. Okay? Alright, so let's look at a second example. Okay? So here we're going to do kind of the same thing. Okay? We have 3/4 times 2/3. Again, both less than 1. So the product is going to be smaller. Okay, so let's look. 3/4. 1, 2, 3, 4. So I need to highlight. It's a pretty big area. I'm going to go as quickly as I can so we're not spending our video time just doing the highlighting. I'll do it kind of quickly, and then I'll check in the frame to see if it looks... Oh, okay. That looks pretty good. Of course, I'm going to use a different color than orange from the last example. Okay. All right. So hopefully... Oh, good. Okay. I'm going to try green. Now, we are talking about this factor. So there are 1, 2, 3 going this way. Okay. So using green, okay, there's 1/3, right? 1/3, 1, 2, 3. And then we're going to do another third. Okay, 2/3 of it is shaded this way. Okay, now again, in terms of the product, it's all about the overlap section. So this is double shaded, both green and yellow, green and yellow, green and yellow. Here, here, and here. So of the original 12 squares, 6 are shaded. So the product is 6/12. Now again, I'm trying to get this across to you, the conceptual framework, to notice that 6/12 is less than either one of those, because you're not really multiplying, if you just stop and think for a moment or two. Okay, now, again, in terms of the mechanics, the how portion, okay, numerator multiplied by numerator. So 3 times 2 equals 6. 4 times 3 equals 12. In my ongoing efforts to prepare you for middle school, you hopefully would notice, that 6 and 12 are both even numbers, which means they can be both evenly divided by at least 2. However, they can also both be evenly divided by 3, and yep, that's right, they can also both be evenly divided by 6. 6 is the greatest common factor of both 6 and 12. I want you to always think of this as 1. 6 divided by 6 equals 1, and if you divide anything or multiply anything by 1, it equals itself, the identity property. 6 divided by 6 is 1. 12 divided by 6 is 2. Okay? So 6 parts out of 12 or 1 part out of 2. Okay, good. Now I'm getting low on time. Okay, I'm going to do one other example. Now here we have a whole number multiplied by a fraction. Okay? Now this is obviously greater than 1, but this is still less than 1. Here's 2/3. You see it here. It's less than 1. So the product is going to be less than 4. Now, this one's a little more challenging, not impossible, okay? But I want you to understand that the 4 circles represent the 4 holes, right? 1, 2, 3, 4. And then we need 2/3 of each one. Okay, 1/3, 2/3. Okay, I know they're not perfect. I did not use a protractor in setting these up. 2/3 here, 2/3 here, and 2 here. Let me check the visual. Okay, looks good. Okay, so the question becomes how many thirds? Just count them up. 1, 2, 3, 4, 5, 6, 7, 8 thirds. Okay, 8 thirds. Now we're going to get back to that in a moment. Okay, now again, this is sort of the conceptual, this is sort of the why, the underlying concept stuff. Over here you take your whole number, and every year when I teach this, I suggest putting it over 1 just for visual purpose, just for the reason of the visual. I think it looks better for the eyes. 4 times 2 is 8. 1 times 3 is 3. And you can say it there, 8 thirds. Alright, now I'm very low on time, but we have to divide. Okay, so every fraction is a division problem. We've said that many times. It's your numerator divided by your denominator. 3 goes into 8 twice, leaving us 6. 8 minus 6 is 2. And remember, this is a fractional component of another divisor, so it's 2 and 2/3. And if you think about these 3 thirds would make up 1, these 3 thirds would make up 2, and there's the 2 extra thirds. Okay? So multiplying fractions, numerator times numerator, denominator times denominator, simplify or reduce as needed. You don't need a common denominator. That is all.